Hey class, last video here that we're going to do. I'm doing a second video because honestly it's hard for me to find kind of good videos that I saw online to explain this. So I'll do a second question with a different outcome than the first one. So in the first video, example number 1, force applied was winning against both force of friction and force parallel. Let's see what happens in this question. This question is not on your practice sheet. If you're wondering for the answer for question number 2 at the bottom of your worksheet, the answer key is going to be in your file folder, so go look at it there. But this is a question that's not actually going to be on any of your worksheets. So just kind of follow along, and if you want to actually try and do the math on the side, you definitely can. You can pause this video and you can see what you get before I do it. So in this question, we're going to have a mass of 50. So it's a mass of 50 over here. Coefficient of friction of 0.40. Still that same 30 degrees, didn't change that. Force applied of 125, so not as much this time. What is our acceleration? There's our question for this one. So if you want to pause it, try it out. Sounds good. If not, if you just want to kind of follow along with me and see what the outcome is, all good there too. So let's actually start going through this and breaking this apart into our different scenarios. So force of gravity, force normal, let's start with those. I know I kind of get out of screen here a little bit, sorry, but force of gravity, mass times 9.8, I get 490 newtons. 490 newtons. Force normal, which is this here. Force normal. We're going to use our cos function times that 490. So cos. Cos. 30 times 490. And I get an answer of 424.4. 424.4 newtons. Okay. So there's our force normal. 424.4. That's a lot of fours. Should have looked at that beforehand. All right. So there we go. There's our force normal right there. Let's find our friction under that. And again, if you listen to the last video, you'll know that we cannot put our force of friction in here yet. Yes, we have a force applied. Doesn't mean that force friction is always going to be going this way. Technically, if the force parallel is bigger, force friction may be going a different way. So we'll find a force friction. Let's not get too antsy yet, though, of where we're going to put it. Force friction is just mu, your coefficient of friction, times force normal. So 0.4 times 424.4. Holy, it's a lot of force. All right. Our answer for our force friction, 169.8. All right. Lastly, we are going to find force parallel. Force parallel is this right here. That is our actual section that's been pulling down. So I'll draw those lines right here. Force parallel, which is the same as this here. Okay. Force parallel, sine theta. Force parallel equals sine of 30 times our force gravity. So back up here, 490. I got a force parallel. I think of a nice number. 245. 245. Okay. Force parallel equals 245. All right, so now we actually talk about the scenario here. This is where we're going to talk. A little glare is there. It's a little annoying. But our force parallel is pulling down at 245 degrees. Sorry, 200. Wow. It's been a long day. That's okay. Hang on with me here. Our force parallel is pulling down with 245 newtons. All right, so that's how much it's pulling down. So that's how much gravity is really making this thing want to go down the hill. Something else here. Okay, me, I'm pulling at 125 newtons. So who's winning? Well, gravity slash force parallel is winning. It is wanting to go down the hill way more than I am pulling. So that means friction is going to be doing what? Well, if it's wanting to go down the hill, friction is going to go in the opposite direction. So I'm going to put a little blue arrow here. We have our force of friction here. Force of friction, which is 169.8. Okay. So we have drawn all the actual forces out now. Let's try and get our net force. So net force equals, what's the bigger number? Where is this box or where is this object wanting to go? It's wanting to go down the hill because force parallel is beating my force applied. So let's start with that number, 245. 245 minus me, the 125, and then minus force of friction, 169.8. An answer of like negative 49, I think point something, 0.8, 0.2. I'll put negative 49 just to make it easy for now. But why do I get a negative? That is not nice. Well, there's a reason you get a negative, and let's try and think about this. The force parallels 245. I'm pulling up at 125. If I just did these two, the box would be wanting to go down at about 120 newtons. Like that's how much force parallel is beating me. Okay, force parallel is beating me by about 120. Well, force of friction is basically 170. It's way more than the difference between the two. And because force of friction is bigger than the difference of these two, friction is going to be keeping it where it is. Anytime you get a negative number here, that means friction is beating the difference between force parallel and force applied, which means that this thing is going to end up having no movement. Okay, so basically when you get a negative number, as long as you start with the biggest number first, when you get a negative number, that means that basically your acceleration, that's a horrible red, let's try this again. Basically means that your acceleration is going to be 0. Looks like the same red. I gotta throw those ones out. Your acceleration is going to be 0 because friction is holding it in that same place. So that's going to be the scenario where, again, yes, I'm pulling, yes, parallel winning, but the force friction is just too strong to overcome either of us, and so that block's going to stay right there. Okay, so hopefully that question helps you understand, again, just a different way to approach this and how to see it from the, again, the net force side from a different way. All right, your assignment's going to have basically 1 or 2 questions from the front side, only 1 question from the back side, and then I'm going to add in a little video talking part of this assignment where you're going to have to just talk to me about a couple different scenarios. You're not going to have any numbers in that scenario, and it should be a quick little video. So hopefully this video has helped, class. If you have any questions at all, please ask me. I'm always in the building, or I'm willing to help by a little video chat. And hope you have a great rest of the week. Thanks, class.